been taking a look at breaking down radicals. Well, now today we're going to add an extra step to this. And that extra step is going to be now there's going to be a variable or variables hanging out underneath there too. And it's a pretty simple way we can fix that, but we'll get to that in just a second here. So when I'm looking at these, one of the things I have to notice, back like we did before, I can use my help sheet that we had before if I want to do that. I can play with the calculator, which is what I'm going to do today a little bit more, to get us used to that a little bit in case you get numbers that are bigger than what you're used to seeing. But no matter what on any of these, and if you're not going to use your chart, I'd suggest doing something like this maybe towards the top of your paper. We'll even move this out of the way and do this. I've got to remember what those perfect squares are at the start, because those, we've called them our perfect purples, we've called them our radical reds, I come up with a whole bunch more here. But at least going that high, just to remind myself, oh yeah, when I'm breaking down these numbers, one of the two numbers that I'm using has got to be one of those, because otherwise it doesn't break down for me. So once I know those, the calculator can help me a bit. So I start to look and I'm like, okay, I won't even deal with the variable yet. I'm just worrying about the 125 here. Any ideas on maybe what one of those red numbers might divide into 125? Give you a hint. Look at the last two numbers in the number we're working with. 25. So now if you're not sure how many times that goes in, again, there's no shame in going back to the calculator and saying, okay, it's 20, oops, not 28 though. Does 25 go in? It sure does. It goes in 5 times. So it's good to write down those two, and then we break them down. And if we remember back to last week, we go, oh yeah, the perfect one gets out of radical jail on perfect behavior. The square root of 25 is 5. This guy, not so much. But now there's this little extra thing going on. This n is here. Well, what the heck do I do with the n? And it talks about it a little bit right here. We're going to divide the exponent, whatever it is on the variable, by 2. Now, this first one's kind of tricky that way, because you're like, wait a minute, 1? I'm going to divide it by 2. I can't do that. It comes out like 0.5 if I tried to do that. If it doesn't go in a whole time, which it doesn't, because, well, 2 is bigger than 1, we're going to keep n underneath the radical, because normally we just do that with a remainder, but that is the remainder this time. So the n's going to stay underneath with our 5, and we're done. Now, is it always going to work out that way? Well, no. We've sort of played with this over time and seen that that's not going to be the case. Ooh, I see a tricky one coming up on 3 anyway. 512. Okay, let's play. And again, I could use the smaller numbers, but the bigger the number I get, the better off I'm going to be. Let's see if 144, oops. Let's see if 144 works. No. All right. I'm not feeling good about 121. I know 100 won't work. Let's try 81. And sometimes it does. Sometimes it just takes playing around a bit. Sometimes this may take a while. Let's see. 64. Oh, 64 I'm being told it's going to work. Okay. So I do 64 and 8. So I go, okay. So I do my square root. And I say, okay, the square root of 64 is 8. That goes here. My square root of 8 goes over here. But now what do I do with that k squared? So I look at this for a minute and I go, well, I take the exponent, I take the 2, divided by 2. Well, what's 2 divided by 2? 1. So what's that mean for me? It means k to the first power goes outside with my 8. Now, there's a couple of things I'm going to mention here. So if it goes in an even number of times, so it goes in clean, okay, that's always going to go on the outside. If it doesn't go in clean, or I have a remainder, that's going to stay on the inside. But I want to look at my answer for a second here again before I go to the next one. I'm looking at that 8 that's still under the radical. Is there any number up in my list at the top that can divide into 8? Besides 1, of course. 4 can. Like, oh, I'm not quite done. I circled a little too prematurely here. And again, this is just a reminder for when we're breaking down. If we don't get the biggest one, that sometimes this may happen, and that's okay. So I look and I'm like, okay, let me keep this kind of coming along with me. So I've got this 8k to the first, and now the square root of 4, because I can only break down the perfect one, is 2. And then I just multiply the numbers that aren't in radical jail anymore. It can get to be a little bit longer if I don't get the biggest one first. But it's like anything else. Once I kind of get used to it, it doesn't become quite so bad. And I think that's the only one that we'll probably have to break down twice, because we're going to remember this now and it's going to go well. All right, let me get the calculator out of the way for a minute. All right, number 5. Somebody help me with a number from the list that is going to go into 216. I will take any of them, even if it's not the biggest one. Nice, okay. So 36 and 6. And again, the one from the list, we break down, it gets out of radical jail on perfect behavior. The other one, I'm going to leave a little bit of space in here just in case, stays under. But then I look at that variable and I say, okay, exponent, divide it by 2. How many times 2 go into 4? 2. So for however many times it goes in, that's the exponent that'll be on my variable outside. So the k squared goes outside, and I'm ready to go. So it works a lot the same way the numbers do, except I'm using division instead of actually having to use square roots and things. I'm going to try to help out here as we keep going by keeping a list on the screen here. So I get to the next one. All right, we're looking for 80, something that goes into 80. I know it's not 81, I know it's not 100. Pretty sure it's not 64 or 49. 5 and 16. And again, the one that's perfect breaks down. Square root of 16, if I'm not sure, I can punch it in the calculator. It's 4. You're like, wait a minute, how do I punch it in the calculator? Because you keep talking about how we just know these. Okay. If I need to use the calculator for it in here, I would do second and x squared, and then just punch in the number I'm looking for the square root of. So that's where it's coming from. But again, it's just second and x squared. So, okay, so I write this. My exponent's 3. Okay, here's the first really good one we're going to have here. How many whole times does 2 go into 3? 1. But this time, I have 1 left over. I have a remainder. So here's how this works. The one that went in the full time, that's going to give me a p to the first that I put on the outside of my square root. The remainder, what's left, goes with on the inside. So I'm going to have a p to the first in both places. Okay, so how many times it goes in, goes to the outside. Anything left over or remainders is going to stay on the inside. So you're like, okay, this might be doing a little better. We'll see. Biggest part on all of these is that number part, I think, for a lot of you. All right, 147, start playing. The only way these start clicking for you is if you're playing with them. If you're just sitting waiting for mine, it isn't going to click. I'm just saying. The calculator's even there to help. I'm just saying on that too. 3 and 49. So I look, okay, the square root of 49 is 7. The 3 is staying under. I'm going to leave myself some room. And I notice I'm in a situation a lot like I was in the last one. With my m, goes in once, which means I got 1 out here. I got 1 left over, which means I got 1 in here. And again, you don't have to do all the writing out that I'm doing with this. I just want you to be able to look back later and see, well, now why did I do that? So you can see where it's coming from. And then since n is the exact same thing, I do the exact same thing. Ready to roll. I'm going to do these last 2 on the front and a couple of other ones with some twists on the back, and then I'm going to give you some time to kind of play with some of these a little bit. All right, 75. What have we got? What have we got? What have we got? 3 and 25. Square root of 25 is 5. Three stays under. And again, with my x, I have a 2. I divide it by 2. It goes in once. But I don't have any left over. So I only have an x to the first on the outside. Now y, 2 doesn't even go into 1. All I have is the remainder part. So just like we did up in example 1, that y to the 1 will stay inside. So we can have them in both places. 1 in, 1 out. Nothing too shabby. And then this last one actually might be the easiest one we've done, but it also can be hard because we're so used to breaking them apart. Normally I'd say what multiplies to 16, but wait a minute. 16 is a perfect square. It's just 4. Sometimes that can happen. And then I just take my exponents. 2 goes into 4 2 times. I don't have any left over. So that's it for the u. With my v, 2 goes into 3 once. Leaves me 1 out there. Like, what do? I don't have a number left in here to put with this. That's okay. Just put the variable in. And we're good to go, and we're happy about it. The only other twist that I can throw at you with this, the only one, as I get ready to flip over towards the back here, are some of the issues we may run into, let's say, like on number 17 or some of those other ones. I want to take a look at 17, 27, and 29 with you, just so we can get some practice with when there's a number out in front. Keep this in play. Maybe. There we go. All right, I'm going to ignore the 7 for a minute. I'm going to pretend that just is breaking it down, just like I have been. 96. I need some help with 96 here. Which one am I?
6 and 16.
Okay. So we got 6 and 16. So I've got 4, because that's the square root of 16. Got my square root of 6 over here, because I'm not sure what's going to happen with my m yet. And you'll even get used to, once you start seeing these exponents, where everything goes. Because you're going to be like, oh, I remember how 3 goes. It went in once. So I had a 1. And then there was 1 left over. So I had 1 in here too. But what about that 7? Because you haven't done anything with that yet. Yeah. That 7 then gets multiplied by the 4, which isn't in radical jail anymore. So my actual final answer would be 28 m to the first. And again, with the m's, if I don't put the first power there, it's okay. We assume it's a 1. But if you want to put it there, you can. It's an absolutely okay thing to do. All right, last couple. 27 and 29 down here at the bottom. All right, again, ignore the 3. Similar situation we had in the front. 16 is already a perfect square, so that's 4. All right, I'm going to do this without the division this time. How many times 2 go into 4? 2 times, and I don't have any left over. 2 goes into 4 for y. 2 times. I don't have any left over. But then z, 2 goes into 1. Well, wait a minute, 2 doesn't go into 1. 2 is bigger. So in that case, we keep the z underneath. If it's 1, we always are going to keep it underneath. And then my last job is just to multiply the 3 times the 4. And I'm done. So sometimes, again, we won't have a number underneath the radical. If we got a perfect square, that's awesome. All right, one last one. 75 we played with a couple of times here. So 25 and 3, because we always know how to talk in quarters. Square root of 25 is 5. Leave some room here. And then again, just start remembering what you've seen over and over. M to the first. 2's bigger than 1. Okay, the m's got to stay here. 2 goes into 2 one time. No remainder. So the p goes on the outside. Okay, we're just dividing. 2 goes into 3 one time, but this time I have a remainder of 1. And again, if you want to write the division out like we were doing on the first bunch of them, that's okay. There's nothing wrong with that. But once I get it broken down, then we just multiply the 6 through. And we're done. So again, your job for the homework check is to do the evens on this sheet. Okay, that's actually going to be the last thing on the homework check tomorrow. I know I normally don't do that. But in this case, I'm like, no, it's good. We need to get the practice here quickly before our quiz comes up in a couple of days here. And then the other sheet that you've grabbed today, this is going to be towards the next homework check. And this is similar to what we've been doing. Break down the numbers, put together like terms. And we'll talk some more about this tomorrow too. But plenty of time to get a good head start here and have that homework check ready to go.